Now it is my pleasure to introduce you to our moderator. We have quite an international flavor to our program tonight. It's going to be a lot of fun. And Brant Cooper is here as our moderator, who is someone who loves to help startups get started. He's the author of the popular lean startup book called The Entrepreneur's Guide to Customer Development, and he is traveling the world talking to startups, particularly high-tech startups. His book, Cust Dev Book, is required course text at several universities worldwide, and we're just thrilled to have him here to be our moderator for this evening's program, which is, I'm going to get, is going to be a really wild and woolly one. So Brant, come on up and get us going.
Thanks so much, Pamela, and thank you, MIT Forum in San Diego, for continuing to bring really great topics to the San Diego community and to support the San Diego high-tech community. I'm particularly fired up about tonight's presentation because I think some of the issues that we're addressing here are issues that face technology companies everywhere. You know, we've got sort of innovation versus invention. We've got questions about early adopters. We've got questions about sustaining versus disruptive innovation. And so I think that what we're going to find here, and I hope what you get out of this, is that what we learned from some of our expert panelists, you can actually bring back and apply to some of your own businesses. And so the way this is going to work, I'm going to introduce our primary speaker tonight, and he's going to present his company and some of the issues that they're facing. Then I will introduce the panelists, and we're going to have an open discussion, hopefully a back and forth dialogue about some of these issues. And then we'll open the discussion up to the audience. So, you know, I'm sure there's a bunch of bigger brains out there in the audience than myself. So during the discussion, please be thinking about questions that I should have asked. Now, speaking of bigger brains, our speaker tonight is a big brain. He's a big brain guy. And his company is actually building big brain technology. And this big brain technology actually is technology that, well, it acts like a brain. And so Walt Diggelmann, CEO, co-founder of AI1, has flown here from Switzerland to share his company, his vision, and the issues that are facing him. And so I want you all to give a warm welcome to Walt Diggelmann, and let's get this started.
Thank you for the warm welcome and introduction. And okay, so we're ready. Yeah, I brought my assistant here. So, I mean, you have to deal with my Swiss English. So if you don't understand anything, just, you know, wave your arms and we try to, maybe Siri can translate or somebody then. So it's right, you know, that the issue is if you have technology, platform technology, which is very low level, it's not easy to get that into the market. Even if you can solve problems nobody could solve before. And so those are the issues we like to share with you, and I'm hoping I get a lot of response. And if there's something unclear, then you just interrupt and we can clear it right there. So we'll talk about intelligence in computing. And so there was a big hype 20, 30 years ago already. And then some people were kind of disappointed because it didn't show up the way everybody was expecting it should show up. So it took a long time, although that intelligence in computing is all over the place. I mean, if you buy a car today, there is a lot of intelligence in there already. You just don't see it. And it was kind of visual in the last days or months when Siri came up and all the discussion and IBM Watson and so on. But actually, there are some traps there. I played with Watson, and the problem was he couldn't understand my Swiss accent. So he couldn't even show his brilliance because it was dying right there. So intelligence means there are many, many things you need in order to get to the result. And let's talk a little bit about. And I think, you know, one of the things we all know and we've heard about probably, you know, computers are moron. Well, I wouldn't say moron, I would say slaves. Because practically they are as good as the programmers. If you have a smart programmer, you have a smart computer. Or not. And so some of the issues there are that you have some challenges, and one of the big challenges is you don't get any answer unless you pre-program it. So in order to do that, you need to understand your data, you need to understand what's maybe the reason why somebody will ask an answer and so on. So you have to do that all in advance, and that's not pretty intelligent. That's maybe smart made, but it's not as intelligent, and people are upset because that's not what they expected on artificial intelligence. And so another point is, besides that, if it comes into huge data, then it's even hard because you don't even know what's there. And you try to find answers. You know, when venture capitalists come to us and say, you have your 2-minute elevator pitch. Well, that's stupid in a way. How should I explain the world in 2 minutes, you know? But on the other side, it's a good challenge because if you can't come to the point in 2 minutes, you maybe never make it to your point. So then I usually said, well, I don't need the 2 minutes, I only need 15 seconds. And they usually said, try. And I say, AI1 gives you an answer to a question you did not know that you have to ask for it. And usually it's quiet as you are. You're thinking, what does that mean, you know? What does that mean? Well, this is dramatic. So that means the computer knows more than me. So you're getting into a philosophic question now, you know, do I allow that or should he be my slave? So if you like to have an intelligent machine, the good news is it's intelligent. The bad news, it's intelligent. So really those are the challenges. And if you then try to solve all that, you know, let's imagine the computer understands human language. It understands it in a way, in a form that in every language, because it's based on a grammar, there are intrinsic information patterns there. So it's called intrinsic semantic because the sentence is built on a grammar and therefore there's a structure in there. And we as the human, we understand the concept of that language. Let's say you speak French, okay, you understand the concept of French. And so you don't need to know all the words, just a handful, and you can understand the content because the pattern is there. So if we get the computer to recognize what we recognize, we don't have to teach him. And that's really the solution we're looking for. Why? Otherwise, you always have to have models. And if you're part of the model, how should you define the model you're in yourself? So you should go outside, define your model, but then the timeline is going here, and so once you finish with the model, the time is already there, and you're always behind with the model. And that's why ontologies and taxonomies and everything, that's fine, that's brilliant, but it's not dynamic. So if you are in a heavy designed environment, in a discrete designed environment, like a car, so it's kind of defined. You can have a lot of intelligence there because the model is not changing. But if it comes to language, where everything is changing all the time, it gets hard to keep up. And that's where this system is struggling with, really. So if we could have this dynamic, I mean, there are so many things we could solve. I mean, almost in everything where a chip or a battery is inside, you could use it. Making your Hoover more intelligent, making your car, whatever you have, there's a spot everywhere. And that's the good news and the bad news. So if the venture capital guy comes back to me and says, okay, I understand. You can give me an answer to a question. I didn't know that I have to ask for it. So I mean, how could I use it? Where? Which branch? Which vertical? Then my answer could be in all. actually. Because if it's intelligent, then of course you find a spot where you need some intelligence. It could be a very, very small spot with a small action, or it could be a big one with a big, complicated action. But that's bad news also, because usually you should focus and you find the low-hanging fruits. So what we did, first of all, we said it's a platform technology. So we don't have to bother with all the verticals. It's easier. So we have partners and they bother with the verticals, which doesn't make it really easy to explain at one side. So what we really invented or built was we call it holosemantic data space. In this data space, you can draw in data on binary level. So we don't care whether it's an image or whatever you have. And it will show you what's there. It will show you the minimal topography which is inside. Whether you know already what it is or not, that's not the point at this point. I give you an example. Did you ever have a computer where you could store any information in a database and you did not have to define the structure before? It's not possible. You have to tell the structure before you get it in. And so here, it's like a small child. You take a small child, 4 years old, and you walk it on the sidewalk, and you come by a construction place, and there is a caterpillar. Let's imagine this child never has seen a caterpillar before. You walk by, you don't even point at it. You just walk by, the kid will see it. There's maybe a crane in the background, so it sees all that. Now you go home, and you take a picture book. And in the picture book, there are a pencil picture about a caterpillar. Different size, different style, but the kid immediately will spot it and say, well, we just saw it out there. So the kid was unable to store something it didn't understand at that place when it stored it. And that's really the trick we have to do. If we can do that, that opens up a whole bunch of applications and possibilities. And that's really what we do in our data space. You can load information in, and then the system will tell you, it will listen to your data and tell you what's there. It will show you the minimal topography of text, or it show you the minimal image forms in an image. Give you an example. We built a system for shoe tracks. Did you know that in crime scenes, 80% you have fingerprints on a crime scene? It's even higher than 80%, but they say about 80%. In about 60% of all cases, you have shoe prints. So that means even on the floor, on a carpet, on a sideboard, even if I'm stepping up here, they have some special foils and special methods. I mean, you can see that in the CSI Miami and all those series, you know. So they can take this shoe print. But this is a relative universe because it's done usually dynamically. That means the guy was running and he left his footprint, and it's done from a flexible sole. So the image is changing, and then when they catch him 3 months later and he still has the same shoe because he's a man, I only have one pair of shoe. That's really the case, I tell you. But the image has changed. Just imagine you have a sports shoe and he has, let's say, black circles. After 3 months, those circles maybe get concave. So the inside of the circle goes inside because the rubber, you know, gets like, and so you only get a ring now. Now, if you as a human would watch on those two samples, the one took on the floor and then 3 months after, you would see that this is most likely the same shoe because somehow it's the same. It's not the same in detail, but the concept is the same. So you have to recognize concepts and not patterns. And that's really what the technology does in the middle as the core. And the nice thing on the core, it's only about 300 kilobytes. So if our program is here, you know, it's a very small thing you get. So it learns like a human. So that means as more you teach, as clever it gets. It maybe doesn't have the same understanding of the data as you have. It maybe will return something unknown. And so that's what you have to deal with. And also you can train it. So you can go supervised or unsupervised and many things more. So we call it biological inspired intelligence because we think that this is closer than artificial intelligence. I mean, we don't like to have something artificially. It looks like a rose, it smells like a rose, but it's not a rose. A clever system would do a job if it does something I would do and I'm not in the office. It would be clever if nobody recognizes that I'm not there even. Then it's really smart. So as soon as you can see that, you know, it's some like the same, but it doesn't really fit. And that's the other thing on artificial intelligence. As soon as you tell somebody, well, this is intelligent, the level of expectance, I mean, you know, what I expect, what the level is raising up very high. And it's like you're looking at movies like Final Fantasy and so on, where you have the artificial humans. If they are too close, but not really close, we don't like it. Then it's better to have it a little bit on distance, and you kind of accept it, because you know, there is a certain distance. So that's what we have to deal, and we did about 10 years now on research on that. So we had about 5 years of very basic research. So we know what happens if you drop lemon onto aluminium, and then you find out that it gets blue, and then what the hell can somebody need blue on that? So that kind of universal research. So you start somewhere, you find out, okay, then you do about 2 years of applied science. So you find out whether there is a market, or can we push a market, can we create a market, and all that. And then the last 2 years, we started getting into the market and trying to sell it. And so today we have 3 locations. It's Berlin, it's Zurich, and it's here in San Diego. Now, the decision how to sell that kind of a technology is not easy. And we came to this 3-channel strategy. We said on one side we need the science. Somebody has to say, this is brilliant, that's good, so we get some reputation. On the other side, because we're not a spin-off on the university. I mean, all of us had done some studies and stuff in the past, but you know, it's not something which comes out there. It came from the side. The guy who is behind, one of our partners, he had this idea, you know, while he's taking a shower, and somehow then, you know, we came together and we started up that company. So we needed some reputation from the science side, and on the other side we said, well, if we sell to vendors which are doing a solution, then we have to motivate them why they should use our stuff. So we have to show them that there is a market. So we have to talk somehow to the market. But then we need to be experts on all the verticals. We can't do that. So we said, okay, let's do the old trick of SAP. Let's create a lot of consultant people. They're running around in the world. They know what we do. They know what the need is in the market. And they will bring together the customer and the vendor. And then the customer will tell the vendor, I've heard that AI1 can solve my problem. Do it. And then they come to us and say, well, we need AI1 because our customers are requesting it. So that's how we try to get in the market. So tackle it from the top and from the side, at the end user and at the vendor side through the consultant. They have an added value, they make their money there, and so everybody is happy. It's still not easy. We license the technology as an API, as a small API SDK, and then they can integrate to their solutions. And one of the challenges we have is it's an invention and not an innovation. And there is a big gap between the two. If you have an innovation, then it's the next step of something you know already. So, you know, you have an iPhone in black, now you get it in orange. So everybody will believe that this is possible. That's the smallest step you can take. But if you come and say, we all know about driving cars, but you haven't seen a plane yet, and somebody comes and says, now we're going to fly, he will say, yeah, no, don't believe. The step is too big. So you have to find, even if you have this big step inherently in your invention, you have to kind of scale it down so that people will accept you. And so in our particular case, we had a second challenge. Nobody did like artificial intelligence. The name was screwed. When we came up with that, everybody said, come on, forget it. You know, we tried it, it doesn't work. So should you rename something if it is artificial intelligence or what people were understanding on it? No, would be wrong. So if it is yellow, you have to name it yellow, even if nobody likes yellow. So you have to get the people to the point they like it again. So that's a little bit an effort you have to take. So you have to convince them, you have to show that this is good and so on. So that's the first challenge. And then the second one is, there's this, oh, I'm too far. Then you have this gap there. Believe me, and you probably, if you deal with startups, you maybe can support that. If you have a crazy idea, it's relatively easy to find the Fs, the family, friends, and fools, to invest in you. And you get to a certain point. And it's also easy to find the first customer because, he's like, oh, I'm cool, doing that. And you usually find one with some money and he can, it doesn't matter whether it works or not. He will, he's first or not, so that's kind of easy. It's not easy, but it's easy. But then, and I call this process kind of industrializing. You're still on a very technical move and you get these freaks and they buy into that. But then you try to commercialize it. And now you're talking to big corporations, like Bruce is here. And you try to sell them something. You're a nobody, you're a small company, you may be coming abroad. So there's a high risk for a big company to buy into that. And that's really the challenge. Now, the challenge by itself wouldn't be really bad, but the bad is you don't have any money left. Because you get there to that point and you burned all your money, you're finished, and now you try to go out. So that's really the challenge you're in, and that's where it makes you successful or not. And then on the other side, now, how can I? And then again, you're coming back to invention, innovation. So you have to boil it down so that that gap gets very, very narrow. So that people believe, okay, that's relatively easy. There's not a big danger to go into that and so on, and they buy into it. And so that's about the three issues I like to summary up now on this first part. And then it's not invented here, fact and that stuff. So those are really the challenges. And so I'm open for questions and the next step.
Great, thank you, Walt.
Thank you.